So yesterday we talked about classifying polygons. Today we're going to talk about classifying them based on their sides and their angles. So polygons are named based off the number of their sides. So if we look here, these 9 already have names. So like a triangle, quadrilateral, pentagon, hexagon, we know what those are. But when you get past 12, you just call it by the number of sides. So if say it had 13 sides, it would be called a 13gon. So it's just once you get past 12, it's the number of sides. Then with polygons, we still have equilateral polygons, which we know have all sides congruent. Then we have an equiangular polygon that has angles that are congruent, and it can be one or the other, as you see here in these examples. And then you have a regular polygon, and that is both equilateral and equiangular. So it has all of the angles are congruent, and it has all of the sides congruent. Now, the Polygon Angle Sum Theorem, so this says that the sum of the measures of the interior angles of an n-gon is n minus 2 times 180. So what we're trying to figure out is we're trying to figure out, say, a polygon has 15 sides. Well, how many degrees are the angles altogether? And so n is going to be the number of sides. So if we look here at this example, it says, what is the sum of the interior angles of a hexagon? First, we have to figure out how many sides that is. And if we look, we know hexagon, hex means 6, so n is 6. And from there, I'm just going to plug into the equation. So I'm going to do 6 minus 2 times 180. And then if I simplify that, I get 720. So total in a hexagon, so a 6-sided shape, the angles all together equal 720 degrees. Now the next one is the corollary. So this is talking about the measure of each interior angle of a regular n-gon is n minus 2 times 180 divided by n. So again, n is the number of sides. And now this, we're not talking about the total angles, we're talking about each individual angle. So that's why we have to divide by the number of sides to evenly figure out how much each angle is separately. So we're going to try to find the measure of each angle in an octagon. So again, we always have to start off with n. So n in an octagon, oct means 8. So n is going to be 8. And then again, we're going to just plug into our equation. So we're going to do 8 minus 2 times 180, and then divided by n, which is again the number of sides. And that would give us 135 degrees. So we're basically taking the total degrees divided by the number of angles. So each angle in an octagon is 135 degrees. Now in here, we're going to have to apply this a little bit. So first we have to figure out what angle B is. So that's going to be our x. That's what we're trying to figure out. We know all the other angles, and since this is a polygon, I can figure out how many degrees total it should be. So what I'm going to do is I'm going to substitute in all my information. So A is 90 degrees because it's a right angle. B is going to be x. C is 122, and again, I'm just getting these from the picture. D is 95, and E is 110. Now to figure out this side, I have to go by the number of sides. So if I look at my sides are 1, 2, 3, 4, 5. So n is going to be 5. So I'm going to plug in 5 for n. And then I'm going to have to simplify that. So if I simplify the left-hand side, I get 417. So I'm just combining like terms, plus x equals 540. So I did 5 minus 2 and then times 180. And then to solve for x, I'm going to subtract 417 from both sides, and I get x equals 123 degrees. So that is the measure of angle B. So I have to use the picture to plug in my information, and I have to use my sum theorem to know how many degrees should the whole thing be. And then our last example is the exterior angles theorem. So all of our polygons have exterior angles. It's just if you continue the line, you get an exterior angle. So I have those in with the arrows. And so the exterior angle theorem says that the sum of the measures of the exterior angles of a polygon is 360. So no matter what shape it is or how many sides, it's always 360. So you're always going to figure out the exterior angle is just going to be divided by the number of angles that you have. So I'm going to start with 360 degrees because I know that's how much they all equal. And I have to divide that by 5 to figure out each individual angle because there's 5 angles. So if I do 360 divided by 5, that gives me 72 degrees, which would be how much angle 1 would be.